Hi, champs. Welcome back again to all of you in the another Sunday live session. And today we are excited to have a special guest with us, Gautam Bose. So he's the founder and the CTO of Automat AI and used to work at Google Creative Lab. And today Gautam sir will talk about physical computing and how it can be used to solve everyday problems. Thank you so much, sir, for joining us today. And over to you.
Hey y'all, Gotham here. As Ankit said, thank you for the introduction. Hoping to share a bit about my projects in physical computing and some of my work with Automat AI as well. I'll present my screen here and jump right into things. So, as Ankit mentioned, or just as some background, I'll share some of my background, share some of my relevant projects, more about physical computing at Google, and then finally move on to what I think is kind of the next wave of physical computing projects, which involve generative AI at their core. So a little bit about me, I went to Carnegie Mellon in Pittsburgh, Pennsylvania, and I studied design there. There I met my creative partner and longtime friend, Lucas. You can see him pictured right there on the right. After graduation, we worked at the Google Creative Lab for several years, and just this January have branched out on our own to form Automat AI, where we build AI automations for businesses. I'll start by sharing some of my work from college. This was really the first physical computing project that I had done, and it was called Emoto. So let's play the video, and that will give you guys a good overview of how this project works. So that was Emoto AI, and it was essentially a robotic base that you can put your phone on, and it turns into an AI assistant. One key thing to note here is, while we did build this with real servo motors and an Arduino to control it all of the actual animation and interaction wasn't really generated on the fly. It was all controlled with an attached laptop, but it allowed us to film the video that put the concept out there and get some more traction around this idea. Um, Here, I'll show you some of the early prototypes that we had in our studio. This one is pretty unfinished, and you can see what happened before we had implemented smoothing on the servo motor code itself. Uh, so you can see that the motion is incredibly jerky, and it doesn't look very lifelike at all. This led us down a whole rabbit hole of investigating how to make an Arduino control servo motor better. And by the end, we had something that worked a little more like this, where you can see the motion is fluid and easily controlled by the linkages themselves. This kind of gives you an idea of how the actual wiring and construction of the robot was. We also used mock-ups like this that had no electronics, but were just there to give us a clearer idea about the animation and what type of movements we wanted the robot to be able to perform. Finally, we spent a lot of time documenting this project, and that's something that I just want to stress is incredibly important for building physical computing projects. Filming the video and taking the photos may not seem like the actual fun part of it, but is really key to getting the word out there about your project. So we sent up like a little roll of paper and a little light, and we're able to get pretty high quality documentation of our project without really a ton of professional equipment. This led us to creating a second version of the Moto project, which I'll share now. So with this project, we were able to bring a fully wireless design as well as a much cleaner wiring, integrated wiring loom. We also were able to film a video that had several new use cases that we thought were a lot more practical than what we had put in the original video. And as well as just, another year brings a lot more experience. So sometimes doing a version 2 of your project, you can really um, flesh out the project with ideas that you might not have been able to execute on the first time around. With these two projects, Lucas and I were actually able to get the opportunity to work at the Google Creative Lab. So really, we put our heart and soul into these in school, and then we were able to continue that work on at Google. We got access to this amazing new shop, and with that comes a bunch of new tools, but also a lot of responsibility. We really have to deliver amazing work because we have a ton of resources being put behind us as well. So the first project that we worked on while at Google was called Teachable Sorter. And I'll play a YouTube video here that shows how this project works.
Sorry to interrupt. It's not audible.
Sorry, there's an audio issue here. What are you saying? I'll play the video. I kind of click through it quickly just in case the audio is not coming through. But essentially, this project, created a sorter that could very quickly sort marshmallows from Lucky Charms cereal. A kind of fun problem, but allowed us to show off the technology. There's me eating a huge bowl of Lucky Charms marshmallows right there. We developed this project to show off the potential of Google's on-device machine learning accelerator, the Coral TPU, as well as the tool Teachable Machine, which allowed you to build an image classifier in the browser with no coding required. You'd simply collect samples of the two different classes and then hit train, and it would do deep transfer learning in the browser to actually build out a model that you could then deploy onto the Coral TPU. That gave it incredibly fast inference times, on the order of maybe 2 milliseconds for this size image. So we obviously had to make the hardware very fast to account for that as well, and used a solenoid to actuate the little divider. As part of this project, we were able to publish instructions as well as a lot of open source code, which is always a good thing when working with a hardware project, to be able to get more and more people involved with any sort of project like this. So the behind the scenes looks a little something like this. It's a lot less polished than in the video, but we had basically to build up this machine very quickly, and we had a ton of tools that we were just had out on the desk, and then had to kind of put them all underneath the table to film properly. The early prototypes were pretty humble. We had a ton of 3D printed parts, as well as just wiring going everywhere, and it took us a long time to actually come up with the final design that we used on the video. And this is kind of somewhere that it separates from a hobby project to a professionally produced project. Is like if we were just building this for ourselves, we would probably just get it functional and then leave it there. But when you're making something for Google, it had to be really explainable, digestible, and just appealing visually. So we spent a lot of time on the design and visual aspect, as well as just the functionality. Here's some more early prototypes. You can see we use a lot of 3D printing in our process, as well as just kind of cobbling together anything we can. So plywood, foam, whatever it really takes to get a prototype up and running. And from there, you can refine it and polish it. We also created a second version of this called Tiny Sorter. So this was a project that is a much simpler version of the actual full-size sorter. So with this, it uses your computer's webcam, and it actually sits right on top of your laptop. And from there, it uses an Arduino and Teachable Machine as well to kind of perform the same basic sorting task, but it's with tools that you would easily have available. So a printer, a small micro servo, and then an Arduino. There's no extra wiring or 3D printers or anything that, a lot of uncommon tools that we use for the larger sorter. And funnily enough, this project actually gained a lot more traction in terms of people reproducing it. I'll share some examples after this, but essentially, because it's so accessible, you just need this printout and then the Arduino and a servo, which are pretty common in most physical computing shops. A lot more people were able to build their own versions of this. So I'll share some examples of that here. But yeah, essentially we've seen STEM clubs all over able to reproduce their own in classrooms and for projects just with Chromebooks or other smaller, computers that would be common with education. Part of the power of Teachable Machine is that it runs, fully in the browser. So you don't need any special software there. So we can see people have made kind of their own guides and really made this project their own, which is great to see. So he's, kind of showing people how to set it up, and then we'll see his finished sorter here that sorts red and green like Italian candies. I'm not really sure. So that was the sorter project, and that was our first project upon landing within Google. After that, we worked on a project called Yes No Machines. This was essentially taking that idea of like a image classifier and using it for a bunch more applications. So we built this little machine that could on device train on image data sets. So in this case, it would be like, oh, is this pancake ready or not? And as soon as it was, it could trigger, say, a solenoid, which would hit a bell. With the power of like this binary image classifier, it's really simple to understand and creates this simple loop of like an input, a decider, yes or no, and then an output. We created this hardware prototype, which shows kind of how a device like this might work. It has a small LCD screen built on top of a Raspberry Pi with a custom printed circuit board that Lucas and I designed. We also, again, filmed a bunch of use cases and spent a ton of time documenting this project. The key here was really to make sure that if people wanted to like create something like this, they would have a really clear jumping off point that would give a bunch of real world examples that seem practical and fun. You can see some of the early versions of this prototyped a lot with cardboard. We built a lot of like kind of specific versions, like has the dog been fed? This is another
Hi
video
everyone,
that
I'm
we
Gautam,
filmed
and I'm going to show you
that shows how an early prototype of this machine could be used to detect like if a fruit plate had been reloaded within your office. The pandemic did hit during this time, so we had to move our full shop into Lucas's basement. So we were just like literally soldering, sitting on the ground, and didn't have a ton of tools. Here's another kind of exploded view of the board. So you can see we have on the front the screen, the controls, then we have the Raspberry Pi sitting behind that, and then finally the Coral TPU. The next project I worked on at Google was called TensorFlow Lite for microcontrollers. Share the video here. This project showed how we can use the same image classifier model from Teachable Machine on even smaller and cheaper boards. So while we had the Coral TPU and Raspberry Pi, that cost about $150 together. Whereas now we can run the model on an Arduino Micro, which is $20. And it's a lower quality model. It has to be shrunken down, and you do lose some fidelity with that. But at the end of the day, there's so many applications that you can reach when you have such a tiny, low power, low-cost board that can still run an image classification model. So we made this video to show how we're taking, these big models that run in data centers and running them on microcontrollers. And there's just, as I was saying, like a ton of applications just because you can shrink the board down so much. We developed a bunch of experiments here that use the TensorFlow like for microcontrollers. So different, like a little drum kit, a finger interface, just a standard like motion classifier, and then finally the a visual experiment. So this is what I actually developed. It was called Morning Mountain. It was a project where by the end of it, you would have an alarm clock that would force you to do a yoga pose to deactivate it. And you can see all the instructions that are put together here, including wiring and how to run the code. The model does run in black and white, so it's a little lower fidelity, as I said. But you can kind of see how it looks. This is like the camera view from the Arduino. So if you go into the yoga pose, the wake up class is activated. The final project that I worked on at Google was the AI Test Kitchen. And this was my first project that was shipped with generative AI. It basically had 3 demos. So this is based on Google's version of ChatGPT called Lambda. The one I mostly worked on was called Talk About It. And essentially it would allow you to have a conversation with a tennis ball. And it was just really cool to see the power of large language models and the flexibility of how they could work. My kind of takeaways from building physical computing projects at Google is that you have to be constantly aware of these kind of different spectrums. So, when you're doing something on your own, it's really easy for it to just always be like something that's super fun. But when you're trying to show the potential of some technology, you kind of want to have it somewhere on the spectrum from like fun to practical, and have it be something that you could imagine using every day, but also has an element of fun in it as well. And yeah, to like maybe give a more concrete example of that with the teachable sorter, for example, there's tons of like incredibly important industrial applications of sorting. And to bring that technology to some sort of like, pretty whimsical use case of like Lucky Charms, marshmallow, and cereal, points at that, importance, but also gives people a fun jumping off point and point to connect with the project. The next thing is to think about like approachability versus having something that's really polished. So again, like to look at the sorter example, the big sorter was really polished. It was a big production, but it's not what ended up getting the most traction. The tiny sorter, which was still well produced, but was a lot more approachable, ended up being a lot easier for people to connect with. So whenever you're building a project, like you want to put a certain amount of polish on it, but you want to make sure that if you're trying to get this out into like the open source hardware realm, that it doesn't completely depart from the realm of what people can imagine building, like what makers are really used to seeing. The final point here is like on this idea of something that's very serious versus something that has more of an element of whimsy and magic. And for that, like I think it's just really important to consider like very serious projects being stuff that has a really important everyday use versus stuff that is just there for fun and is just there to exist like as a standalone physical computing project. But like again, with physical computing, we're not trying to build manufactured goods. That's a whole different realm. So it can be a little more whimsical because it's not mass produced. It's just a one-off object that you've made. That being said, like you almost want people to pick it up and imagine like, oh, I could see this as a mass produced product with like, maybe a whole list of changes, but having just that undertone and like grounding for your project, I found to be incredibly important. And then the final point that I just really want to stress is like building good documentation for your projects is the main way that people will see them. No one's going to actually see the physical object that you made, but they will see like the photographs, the blog post, the video, whatever documentation you create for that project. So it's not uncommon for us to spend, as much time building the project as we did creating the documentation for it. I think that's something that a lot of makers kind of overlook. Because at least for me, like I enjoy the building process a little bit more than taking pictures and shooting videos, coming up with scripts. But as I said, like most people are not going to actually see the physical thing that you made. They're going to see the documentation, and putting that out in a really high quality, compelling way, I think is really important. And it can actually be easier these days. Like, if you spend time like with your iPhone, just time lapsing your build process, you could create like, clips for your documentation really quickly. And now I want to share a bit about my current work, Automat AI. So this is the company that my co-founder Lucas and I founded in January, and we build RPA, so robotic process automation. Essentially, it sounds like robots. I just showed you some robot videos, but actually, it has nothing to do with robotics. It's purely software automation. So you imagine a bot that can kind of click and type like a user would. We work with a ton of different industries such as insurance, e-commerce, healthcare, financial services, and we have several different kind of primitives that we look at. So we can use text to build an automation. We can use documents, so we can extract like any image, any information from arbitrary documents, and then finally we use video, so we can turn a video into an automation using generative AI. So you kind of create, our customers will create these videos and then send them over to us, and we can deliver running automations a lot quicker than traditional software. We entered Y Combinator in January, and since then have been named like one of the #1 AI companies, which is really incredible to see, as well as been featured in publications like TechCrunch. And I want to close out with this thought here of like, what does the future of physical computing look like in a world where generative AI is incredibly powerful? I just created this example right before this. I put a picture of a Lucky Charms cereal into GPT-4 Vision, and with a bit of prompting, is able to clearly classify, what is cereal and what is a marshmallow, pretty much out of the box, right? So it's like really does beg the question of what is the role of these traditional image classifiers when we have one large model that can perform all of those tasks probably to a degree better than those purpose-built models. And the way that I kind of see this going is like two different sides of this spectrum. So in one case we have like the on-device machine learning, and that's kind of what I showed earlier, with the Coral TPU. And I think that we'll really struggle to compete with these like large models that are served in the data center. And in that case, like physical computing really becomes about bringing inputs and outputs from the physical world, and then having that communicate with like hosted web servers that are actually doing the AI inference. It just becomes a lot more powerful when, instead of like going through the whole process of training a model, I can just access the OpenAI API or an open source model like Llama, and build the same task in orders of magnitude quicker without having to gather a ton of training data, etc. So yeah, I'll definitely leave off there, and appreciate Ankit, you for giving me the time to share that today.
Yeah, thanks, Gautam, for sharing your knowledge. So I have some questions.
Okay.
So suppose if someone has some idea to make any device or project.
Yeah.
So according to you, what should be the process to break down that problem into smaller steps or tasks?
I think the best way to start, especially with physical computing projects, is to think of like, what could I make right away with like what I have available that will give me an idea of what the final version will look like. Something we said a lot at Google was like skip to the end. So instead of thinking about, okay, this is my end goal, what are every single step I need to, complete to get to that end goal? Because that just becomes a big task, is to think of like, how could I simulate what it would be like right now to have that, finished project in my hand. So whether that's like, just mocking up everything that you want in a video, for example, or even a slideshow, like you can really start to build out like the idea before actually even getting into like the nitty gritty of prototyping everything. So yeah, I just really encourage people to like think about the experience that you want to give to your user or to create, and then work backwards from that and just start like, how can I create that experience as quickly as possible? Look for shortcuts, look for, ways to kind of step around the main problem and not just jump like headfirst into really like hardcore trying to engineer everything.
Yeah. And one more, according to you, what the criteria should anyone consider while selecting or choosing a microcontroller or hardware for any project?
Yeah, I mean, I haven't really been keeping up with the stuff as much these days, but at least for me, like I really look for the basics like analog input and output, so a good ADC on board, probably enough GPIO, so maybe like 12 GPIO pins. I look for like decent current protection, like something that I think Arduinos have pretty well, but like when you're driving LEDs and stuff like that, you want to make sure at least the circuitry can handle the actual like current that you're looking for. And then with the actual microcontroller, I think you want to try and get like at least a few megabytes of RAM these days. I've seen Arduino, you could get 4 MB, stuff like that on the nicer Arduino. So I just try and get as much memory as possible for what you're looking for.
Okay. So once again, thank you so much for your valuable time, and especially since you wear two hats at the same time, founder and CTO.
Yes,
Yeah,
thank
thank
you
you.
so much, Ankit, for inviting me. And yeah, um, thank you. Cool.
And champs, if you have any question after that session, you can also put your question in the live chat. Thank you so
Yeah,
much for joining.
of course. And I'll also share my contact information with Ankit. So if anyone has questions about this stuff, please feel free to reach out.
Yeah, sure.
All right. Thank you.